And this is some other diagram. Read the question. We have a cone. Read carefully. So some two-dimensional motion, rigid body motion in two dimensions, what we are discussing. I'll construct the diagram. Meanwhile, you put effort. There's a cone of rough diagram. The cone is rotating, so it is able to understand this particular thing. So this line O1 and O2, O1 and I think as in the question he has made C. O1 and C will be at same horizontal line, and this particular some structure. They will be at same horizontal line. Means exactly what is this? This distance will become equal to R. This is some, you can select a inch. Don't bother about it much. I'm going to rotate now. So there is two angular velocities. So one, it will have a spin like this. Then another, it's a spin. So because of this omega 2 like this angular velocity, let me call omega 1. I think that's what the question is asked. Now the velocity of this particular point will be V. This will be linear velocity of the center of mass. And that center of mass will move in a circular path. It will move in a circular path that will show it in another circle like this. Okay, agreed now? So that center of mass will be moving at a height on the ground, at a height r in circular path. And let L be the length of, so let L be the length of the cone. Small l, I'll take it. O1C. So what is O1C? Height of the cone. Okay, these are the assumptions we are making it. Okay, let's come for this one. Don't bother anything. Don't get scared. So this particular rigid body, what happened is having now two-dimensional rotation motion. Is it rotating about x-axis? S. What is the angular velocity? Omega 2. It is rotating about y-axis. S. It is with angular velocity omega 1. So you can take the axis here. So this is the x-axis. This is the y-axis. Okay, let's define one by one. We have from the cone, let me take half angle cone. So what is, we have a triangle here. So what is tan theta? Tan theta will be L by R. Let's get into this one here. What is V? You can write it. There's no slipping is telling without slipping or a horizontal plane. Where is the horizontal plane? So I'm not seeing horizontal plane. Yes, this is the horizontal plane. I think I can't show more than this three-dimensional diagram is there. So this particular edge, now it is in contact with the horizontal plane. No slipping occurs. So no slipping occurs means V equal to R omega 2. the very first idea. So about for no slipping, what we can write, v equal to r omega 2. Then it is also rotating about y-axis. Then v will become tangential velocity. The center of mass will move in a circular path of radius L. Will I agree? Center of mass C moves in a circular path of radius L. So therefore, what is v is equal to? I think I'll write nearby it only. So v is equal to L omega. I think this is the crucial part of the problem. If you are able to break up this much, so like this, that tangential velocity, linear velocity of what is v? What is v? Finally, what is v? Tangential velocity of center of mass of C, and that v is what related to both omega 2, omega 1 by this condition.
Sir?
Yeah.
So shouldn't tan theta be r by L?
Oh, okay, yeah. So what I wrote diagram. Oh, yeah, thank you. Yeah. Now after this, what he's asking? He's asking find the angular velocity of the cone and angle it forms with the vertical and angular acceleration vector. Omega 1, omega 2 are constant. Magnitude is constant. Not omega 1 bar I'm writing omega 1. Only magnitudes are constant. So definitely the answer B will be 0. Let's see, is it 0 non-zero? Fine, till here no problem. I think everyone will accept here. Okay, let's come for this one. Omega 1 will change direction. No, omega 1 will be always directed along y-axis. I'll get into the major part of omega 1. Omega 1 bar is constant, I'll write it. Constant and directed along y-axis. What about omega 2? At this instant, omega 2 is along x-axis. Now, after some time, will be in this direction. Will be like this, will be like this, will be like this, will be like this. I agreed, all of you? Omega 2. So omega 2, what happens? Shall I say omega 2 vector is rotating. Omega 2 magnitude is constant because v equal to r omega 2. V constant, r constant, pure rolling. But omega 2 direction, what happened? Will be along x-axis. Now it will be there in the, suppose this is the z-axis out of the plane. So it will lie in xz plane. Then again at one instant it will be along z-axis. And somewhere it will be between xz plane, x minus xz plane. So then at one instant it will be along negative x-axis. At one instant it will be along negative z-axis. Will agree? If you can get this, problem is over. So take some cone and rotate. No, why you are fighting with notebook? Huh? If you really want to become engineer, analyze one physically, finish your what I'm speaking, you'll catch out. Huh? So how to get a cone? You don't know how to make a cone. Take cucumber or gourd, anything. Swarakai, I think you call in Telugu swarakai, no? Make it cone shape, finish your no. Or take paper, make it cone and whirl it. Okay, no, let's get into this one. So there is an angular acceleration because what is the definition of alpha? When there is angular speed changes or direction of angular velocity changes, it's said to be angular acceleration. So now there is an angular acceleration due to what? Due to change in direction of motion. Omega 1 will be along y-axis, but omega 2 what happened? Will continuously change. So what happened to resultant omega bar? It is changing direction. Due to the change in direction of omega, there is angular acceleration. That is asking. So at one instant, omega 2, so let me get into, so here, now first let's look at this circle. So that dotted circle, I'll put it. How omega 1 will show it. Omega 1, we are showing it in this way. So what is the radius of this? This is L, no? Then it will make an angle delta phi in an interval of time at t equals 0. It is here, t equal to delta t. So how you define omega 1? According to the angular velocity omega 1. What is delta phi? Angular distance. The center of mass c what point will move in a circular path. The c which is here after some time will be here. No? I think I'm giving enough best diagrams. Huh? At least you should able to understand. And this is L. So what is omega 1? You can write it. Delta phi by delta t. Angular velocity of this. Meanwhile, in that interval of time, the omega 2 initially will be a no. And after some time, able to get this omega 2 vector, you see it got rotated, no? So now is there any change in angular velocity of this one? Delta omega 2, let me calculate. Delta omega. Why that delta omega? Due to change in direction of angular velocity omega 2. How to calculate that one? It's a vector. Earlier omega 2 bar like this. After some time, will be like this. I want that change. So how to bring that change? So this is the initial. This is at t equal to 0. This is t equal to delta t. So how you bring initial final minus initial. So the delta omega, how it should be directed? Somewhere like this. Vector subtraction. So delta omega, what you can write? Omega 2 minus. Find the delta omega bar direction. Justified. Okay, no. What is delta omega? How to calculate? Go for vector subtraction. Omega 2 square. Omega 2 square. 2 omega 2. Omega 2. Cos of 180 minus delta phi, shall I write? Why 180 minus delta phi? Angle between those two angular velocity vectors is how much? I think I'll make it small a little bit so that, yeah. Now everything is available. Just do analyze cleanly. So angle between omega 2 and minus omega 2. See, omega 2 is velocity vector. This is the initial, this is the final. The initial one, I'll put like this. This is the initial. Agreed, no? And omega 2 is what? Final. So angle between them will be 180 minus delta, no? Delta phi. So substituting this, how much I'll get? Delta omega is equal to, finally this will be omega 2, 2 sine square 2 into minus cos delta phi. So if I solve this, I'll end up 2 omega 2 sine of, what is delta phi? Very small. The interval of time delta t I took very small. So sine delta phi will be very small. So finally, how much delta omega will become? Omega 2 into delta phi. What is the final answer will be? Keep it here. How you define angular acceleration? What is finally delta phi? What you can write? Omega 1 into delta t. I think I have almost everything data in front of me ready. 1, I'll call this is 2. So therefore, what we can write it as like a delta omega is equal to omega 2 delta phi. Delta phi, what you can write it as? Omega 1 into delta t. How you define angular acceleration? Change in angular velocity by time. So omega 2 into omega 1. How they are directed? How that alpha should be directed? How that alpha should be directed? Is it correct? It will be, yeah. No, omega 1 will be downward, no? So somebody, wait. It's like, okay, thank you. Is it okay, no? So, because I took that one, no? Curl fingers, then the thumb will be in the direction of omega 1. Omega 1 will be along negative y-axis, omega 2 will be along positive x-axis. Then you omega 2 into omega 1 is telling. That is what the alpha. And what is the angle between them? 90 degree. So therefore, I'll bring one very beautiful relationship. So what is the formula? Omega 1 cross omega 2. This is one generalized formula. This is the direction of alpha. How alpha will be directed? Curl it from omega 1 towards, so omega 1 is along negative y-axis, omega 2 is along positive x-axis. Curl from omega 1 to omega 2. The alpha will be along z-axis. The angular acceleration vector. Angular acceleration vector is spelling. So it will be along negative x-axis. This is due to what? Due to change in direction of omega bar. This is due to change in direction. This is not due to change in magnitude. So why this alpha? This angular acceleration is due to change in direction of omega bar, not due to change in magnitude. And it is given by this much. But what is the question is asking something value, no? And omega 1, omega 2 not given, we assumed it. I think we have radius, we have v. Can we bring omega 1, omega 2, omega 1? I think we have alpha and radius, slant length, and omega 2, omega 1 is needed. So that if you substitute, you get the required answer. So let me get into the calculation part. And this is a theoretical idea now. So what is alpha? Alpha is, what is omega 2? Omega 2 should be equal to V by R. And what is omega 1? Omega 1 should be V1 equal to L omega 1. So V by L. And what is L is equal to R by tan theta. So therefore V square tan theta by R. Will you agree? I think that this was the data given for us, no? This is the magnitude. So why do this alpha? This alpha is due to change in direction of motion. So get in this one. So I think see like a two-dimensional when you go it, no? Like that, you have to check even the angular acceleration will be there. So then angular acceleration is there means then it's having moment of inertia. Then there must be some torque. Then who is applying torque? I think somebody should rotate it, no? Somebody, in fact, I'm applying some torque because of that it is rotating. And if you calculate moment of inertia, then you get the torque that one. Now, what is the angular momentum of this one? Anybody? Angular momentum. This alpha you will not accept. So therefore, I'll take help of angular momentum. The same diagram. Let's calculate angular momentum. At least I think you can see that from angular momentum, you can say, yes, sir, like there is angular momentum is there. I'll come for angular momentum. Yeah, come for. No, is there any angular momentum? Yes, there's angular momentum along x-axis. How much it is? Ix into omega 2. There's angular momentum along y-axis. How much it is? Iy into omega 1. What is the total angular momentum? Lx into Lx bar plus Ly bar. I think if you put in terms of this will be Ix into omega I cap minus j cap. So this will be Ix omega 2 I cap minus Iy omega 1 j cap. Now see that This L bar is not constant. L bar is varying. So if L bar varies, means there should be some torque acting. If torque acting means there should be angular acceleration. At least will you accept your teacher? But sir, we don't know moment of inertia. Can you go back to moment of inertia chapter? I told you how to calculate for a cone about its axis and also about this point. So if you want to find out angular momentum about this one, what you should do? See, this is the use of moment of inertia. You should assume a strip if you're calculating about this axis. So this is a circular disc. First find out moment of inertia of this. Mass this be dm. Then you'll get the Iy. Then similarly about this axis,